Before we move on with our discrete math, it's important that we define the different types of numbers so that way we don't waste time going back to this every time we learn a new concept. It's important to take this time like we did taking time to define what even and odd numbers are. So we're going to take some time to define the different kinds of numbers. Now, the first one, as I mentioned in the first video, are the integers. So the set of integers is denoted with this weird looking z, right, with like an extra line, right? And so we say that the set of integers, which is denoted by the z, is equal to, and we'll use curly brackets when we talk about sets, is equal to all these whole negative and positive numbers. So we start with like dot, 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 -3, -2, -1, 0, and then hopefully this pattern is clear enough for you to understand what constitutes an integer. So here's our set of integers, right? And now we want to look at the set of natural numbers. Now the set of natural numbers, which we denote with this weird looking n with an extra line, is just equal to all the non-negative integers. Now what's important is that 0 is included with our non-negative integers. So our set of natural numbers will be 0, 1, 2, 3, you get the point, dot, dot, dot. And now we have our set of rational numbers. Now, how are we going to define our set of rational numbers? Now, this is a weirder symbol. We draw a Q, right, with like some extra lines on both sides. It's very difficult to draw. So this denotes our set of rational numbers, and this we're going to say is equal to A over B, provided that A and B are in, and we use this symbol, this little weird looking E, to say in. So we say A and B are in the set of integers, and B does not equal 0. Now let's think about this one for a little bit. This one isn't as clear as the past two we just did. So we're saying Q is the set of all A over B, right? A and B are in the set of integers, so that means that A and B are integers, right? And B cannot equal 0 because we don't want to divide by 0, right? So let's think about this. What are some examples of rational numbers? Now we could say 1/3. Here, let's write these out in a different color. We'll say that, we'll use purple. We'll say that 1/3 is in the set of rational numbers, and I'm going to just write a Q because it's easier. 1/3, right? Because we could say our A is equal to 1 and our B is equal to 3, right? We could say, let's say -5 over 7 is in our set of rational numbers, right? Because -5 and 7 are both integers, right? What else? What else can we say? Well, we can say that 0 is also a rational number, right? 0 is a rational number because A can be 0 and B can be literally any integer. 0 divided by anything will always be 0. Likewise, we could say that any of our integers are in the set of rational numbers. We could say that 5 is in the set of rational numbers. Why is that? Because our A, our numerator, can be 5, and our denominator, B, can be 1. So it's important that we understand these because we're going to use these definitions of integers, natural numbers, and rational numbers to our advantage when we're trying to prove or disprove certain mathematical conjectures. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.